So a big part of rational expressions is the factoring part. It's really important that we are able to factor well and know when the appropriate factoring is. So we always should start with the greatest common factor. So here we have 4x minus 8. To simplify this expression, we want to factor the 4 out. The denominator, we're looking for two numbers that multiply to negative 10 have a difference of 3. So we're looking at x plus 5, x minus 2. We should always be aware of dividing by 0. So our restrictions are going to be x is not equal to negative 5, x is not equal to positive 2. We have to state restrictions before we cancel, okay? Because although we're going to cancel these because they essentially undo each other, there's still a restrictive value at x equals negative 2, at x equals positive 2. And if you recall from when we tried to analyze this with a graph, there was actually a hole that occurred there. So there is, although it doesn't affect the graph, the shape of the graph, there is still that part of the graph where this is what we call a restricted value. Okay, so state the restrictions first, cancel. Our simplified rational expression then is going to be 4 over x plus 5. So here we have in the numerator a leading coefficient of 2. We always should check for a greatest common factor. There doesn't seem to be a greatest common factor here, so we're going to have to factor that quadratic with a leading coefficient. So I'm going to use my diagonal product strategy and use a 10x squared. And the 10x squared allows me to decompose the 11x, because we know that these two areas add to 11, and this cross diagonal also multiplies to 10x squared. So we know this has to be 10 and 1. Okay, now we can factor. We can just get the common side length along each side here. Common side length between x and 5 is just going to be 1. So it's going to be 2x plus 1. The common side length vertically here is x. The common side length between 5 and 10x is just going to be 5. Okay, so there's our factored form of the numerator. Okay, now you may have some other strategies, some guessing and testing strategies, but this property of this cross-diagonal product, allowing us to decompose the middle term, is very useful. For the denominator, again, we should check for greatest common factor first, because if we do, we would avoid having to factor a leading coefficient. And in fact, if you factored using this method, you would have to factor one of the factors again, because there would be an extra factor of 2 involved. So here we're just going to first of all factor out the greatest common factor of 2. Okay, and then we're looking for two numbers that multiply to negative 10, add to positive 2. Well, that's exactly the same as what we had there. Okay, so we're going to we end up with 2. We end up with x plus 5, x minus 2. Okay, state our non-permissible values. X is not equal to negative 5, positive 2, same as above. And we can now cancel a times with a divide. Okay, and we're left with 2x plus 1 on top, 2 times x minus 2. Don't cancel these out. Again, remember that 2 is not part of a factor. The whole thing now represents a factor.